So, Assalamualaikum and good evening to Dr. Nabila. Here, I would like to explain about my project to assignment, So, the project and assignment that we need to do is a allo design for a RISC vCPU. So, logic circuit and waveform simulation in quarter prime. So, this is a full adder that we already execute. Okay, full adder is a digital circuit, as you guys know. This is the waveform that we obtain from a full adder circuit. Okay, for the input 110 and the carry is 1, the sum of the input for the uh, full adder will become a 0. Okay, will become a 0. Okay, 0. The output sum and the carry is 1, will become 1. So we move on to the full adder. This is the waveform for full adder. And this one, we move on to the 4-bit binary adder with a subtractor, which is this one. Put this up. Okay, this one. We obtain a waveform for this block or this diagram. We obtain like this, which is the input for A. Okay, the input for A not A1, A2, and A3, A0, A1, A2, and A3. We obtain like this 1 0 0 0 for the A, and B we obtain is 0 0 1 0 0 0 1. Sorry. Okay, for the first carry we obtain is a 1. The carry in enter it a 1, and the carry out for it is a 0 1 also. So the output that we obtain by using a adder with the subtractor, we will obtain the output for this one is 0 1 1 0. After this output, we group it together. Okay, so we'll obtain this output. Okay, so we move on to the 4 to 1 multiplexer. So for 4 to 1 multiplexer, this is the block diagram. And the output that we obtain from this one is an input. Okay, so as we can see in here is an input, which is 1 0 0 0. And the selector here we have 0 0 and 0 1. So okay, we focus on the 0 1 selector. We got 0 1 selector, and the Y will be the 0. Okay, as you guys can see here, that's when the bit selector is 0, the first MSB 1 is selected of Y. If the selector is 0 1, selector 0 1, the second bit of 4-bit input will become 0 instead of Y. Okay, so we'll move on to the 4-bit to 4-1 multiplexer, which is this one in the circuit, 4 multiplexer. Okay, this one. So we will obtain like this. The block diagram that we will obtain is like this. Okay, as you guys can see, okay, I help you to zoom it out. Okay, for the I0 here is 1101. This is the I0. Okay, 1101. And for the I2, we got in 1101 also. For the I2 is 1101. For the I3, we got 0100. This is an example of input. Okay, so 1100 here. And the I3 is 1101. After we group this type of input together, we will get that input. Okay, so when the selector is 1 1, the output will be a 1 1 0 1. Selector 1 1. Okay, so selector 1 1, we will obtain from this 1 0 1 1. Okay, we take this one 1 0 1 1 from bottom to the above. Okay, like that. So we move on to the register using 4-bit D flip-flop. Okay, D flip-flop is basically a store multiple bits of data. Register using a positive edge triggered. Usually positive edge triggered because we doesn't have any bubble in here. If we have a bubble, so we will see the negative edge triggered. So for the clock in here, the simple output that we obtain here is like this. So for the D input, we get a 0 0 0 1. For the multiplexer here, flip-flop, sorry, my bad, flip-flop. This one, after we group it together, we will get like this, 0 0 0 1. And the rising clock here, okay, this is positive edge until the positive edge. And we move on to the positive edge here until here. We will focus on this input, and we will obtain in here is 0 1 0 0 1. And also, we need to focus on the reset. Okay, like here, we got the positive edge triggered until here positive edge triggered, but the reset in here is 0. So when reset is 0, it will continue the what we call the previous input. So which the previous input here is 0 0 0 0. Reset mean when we have a zero reset, the flip-flop will instantaneously become zero. So like this, become zero, become zero. When we make a zero, become zero. So right in here, we get a positive edge triggered. Until this edge triggered, right, we get a clock reset 1. So clock reset 1, we just take the input back, and we just we just write it back. Okay, so we move on to the ALU design. This is one, the big one, the ALU design. Okay, so the ALU design we can see in here. As we want to obtain more clear, we will see it from here. Okay, this is the ALU design, which is first one is 4 to 1 multiplexer. 4 bit to 1 multiplexer, 4-bit multiplexer, which is ada 4 multiplexer, 4 multiplexer. And this one is a full adder with a subtractor. This one. And this one is a flip-flop with a clock and reset one. So, okay, this is one. Okay, for the output we obtain in here is like this. We also provided in this output, but for this output is quite small and you guys cannot see. So I just show it by here. So I just show it. Okay, I show it by here. This one example I already circle it down. So here we got the selector 1 1 and for A, and we got the selector B is equal to 0 1. So for selector 1 1, we focus on the I3 input, which is here. We take it from the bottom, so we will get 1 0 1 1 like this. I already stated. For the selector 1, we will get 1 0 1 1. For selector B, which is the 0 1, we will focus on the I1, which is this one. 1 0 0 1, we will get like this, 1 0 0 1. And the ALU operation here we got is 1. So when the ALU operation is 1, we need to become the A minus B. Okay. When the ALU operation is equal to 0, the operation will become A plus B. But right now, as the example we stated here, is ALU operation is 1. So we need to minus it. And the B input needed to become a 2 complement here. So this the B input needed to become the complement, become 2 complement input. So here we can see the clock signal show the rising edge. Clock signal in here we show the rising edge. If we want to state the output, we need to see on the rising edge also. So in here is a rising edge, and here is rising edge. So I simple skip. Okay, this is rising edge. Rising edge, and also the reset here is 1. If the reset is 1, we just take back the input that we obtained after the operation here. We will get the output like this. Okay, so we will get the output like this. So it already stated that the calculation and the for the circuit simulation also same. So we consider it as a successful program. Right, that's all. Thank you. Thank you. So mana nak ni? Stop.